Okay, so some of the students are leaving. Why? I don't know why. Okay, okay. So those who are present, please take your pen, pencil, pen, copy, then calculator, then IS456. Open the PDF and the last class PDF also. You keep these things with you because now we will start solving some numericals. Okay, so I will share the screen now. I hope all of you can see the screen. Hello. Can you see the screen?
Yes, sir. Yes, sir.
Okay, okay. So I request everyone, please respond. Okay, please respond. Otherwise, it will be very difficult. Okay, please respond. Whenever I ask you some question, if you cannot speak, at least write down in chat box. Okay. Otherwise, it becomes very difficult for me. Okay, so in the last class, I have given you the PDF. I have shared with the PDF. So based on the last class, we will solve. We will now go for numericals. Okay. So as I told you in the last class, determination of moment of resistance is very important topic. Okay, so we will start solving those problems. Okay, so let us see the first problem. Okay, let us see the problem. All of you can see it. If you have pen and paper, you can write down the question also. Okay, find the depth of neutral axis and percentage of steel for a balanced section, a singly reinforced beam using. First question is M20 and plain mild steel bar, and the second question is using M20 and Fe415 bars. Okay, so we have to find out the depth of neutral axis and the percentage of steel which we will use to for a balanced section. Okay, so see the values. This value you will get from table number 21. Okay, from table number 21 IS456 you will get this value. From this from table number 21 you will get the value. Okay, since in the question M20 grade of concrete is given, so for M20 grade of concrete from table number 21, sigma CBC will be equal to 7 Newton per millimeter square. I have already told you before also. So next it is given, we are solving the first question. Okay, second, it is given plain mild steel bar. I told you plain mild steel bar means Fe250. It is written here. So in some questions, it might not be written. Okay, only it might be written that you are using mild steel bar. So if mild steel bar is given, then you have to understand that we are using Fe250. Okay, so for Fe250 from table number 22, you will get sigma st equal to 140 Newton per millimeter square. Okay, sigma. This one from table number 22. Yes, from table number 22. This is mild steel bar. So the value of sigma st equal to 140. Okay. Okay. So next, from this to after getting the value of sigma CBC, we can find out. We can find out the value of modular ratio. Modular ratio formula is 280 divided by 3 sigma CBC. You can put the value. You will get this answer. Next, in the last class, I showed you this equation for a balanced section. K equal to, how can you tell me how this is 93.3? If you have the PDF with you in the last, whatever I have shared with you in the last class, Wait, I will show you. Yeah, this value. You can see the value here. K is, for balance section, K is 280 divided by 3. Next, divided by 280 by 3 plus sigma st. Okay. So here 280 by 3 is 93.33. 93.33 plus sigma st value is 140. Okay. So in this way we can find out the value of K. Okay. So after getting the value of K, we know that depth of neutral axis n equal to KD from this PDF. N equal to KD, this one. For a balance section, n equal to KD. N equal to KD. So put the value of K, it is 0.4. D value is not given, so D will remain same. Okay, this will be our answer. Because we don't know the value of D. D means, this small d means your effective depth. Okay. So since D value is not given, our value of neutral axis will be, depth of neutral axis will be this one. N equal to 0.4D. This will be your answer. We have to find out depth of neutral axis, so we have got the answer. Okay. So next we have to also find out, the percentage of steel. Okay, percentage of steel. So percentage of steel for that, first we need the value of J. We have a relation between K and J. In the last class I showed you in the PDF. Yeah, this one, J equal to 1 minus K by 3. So put the value of K, you will get the value of J. J means your depth of, J means lever arm depth factor. Okay, so after getting the value of J, the moment of resistance for a balance section, MB equal to QBD square. Okay, you can write down RBD square also. Okay, and the value of R was half sigma CBC K into J. I showed you in the last class. This one. This one, RBD square. RBD square or QBD square, it's same. Okay, so R value is half sigma CBC K into J. So we have all the values. Just put the values here. You will get 1.214 BD square. Okay. So now in this question you can see these values are unknown. It is not given. What is the width of the beam? It is not given. Nothing is given. Width of the beam is not given. D is also not given. So it will remain same. Okay. 1.214 BD square. It will be same. This will be our moment of resistance. Okay. Next, we have to find out percentage of steel. So percentage of steel formula is this one. Percentage of steel is this formula. In the last, this is the last class PDF which I have shared with you. This is the percentage of steel. This value. PT equal to 50K square divided by M into 1 minus K. PT means percentage of steel. K means our neutral axis depth factor. M is your modular ratio. These values are all values are known. We have already calculated the values, so we can find out the value of percentage of steel. Okay, so percentage of steel, you put the value. K value is 0.4, M value is 13.33. So 1 minus K. So PT equal to 1. That means we are using 1% of steel. Okay, percentage of steel means 1% of steel we are using in this case. Okay, so let us see the second case. Okay, I hope all of you have understood this one. It is very simple. Only you have to put the values in the formula. If you have any doubt, you can ask me. Okay, in this question, if you have any doubt, you can ask me. In the solution, whatever you can see in this screen, if you have any doubt, you can ask me now. Okay, Hoketo is saying he didn't hear anything. Okay, you can see the PDF. Okay, try to understand this PDF. Everything is given. Read the question. The values are given. You see the PDF. I hope all of you will understand this. This is the simplest one. It is the first problem, so it is the one of the simplest problems. Okay, this is very easy problem, this one. I hope all of you have understood this one. Gyani Jamatia, can you hear me? Gyani Jamatia.
Sir.
Okay, समझ में आया कि नहीं?
Yes, sir.
Okay, ठीक है. So let us see the second problem. Same question. Second part. M20 and FE415. Only sigma st value will be changed. Okay, in the second problem, only sigma st value will be changed, because in both the case you can see M20 grade of concrete we are using. So sigma CBC value will be same. Okay, so for FE415 bars, for FE415 bar, you tell me what will be the value of sigma st. From IS 456, you tell me what will be the value of sigma st. All of you see the IS code and tell me what will be the value of sigma st for FE415.
Sir, in my screen, the page is not visible.
Page is not visible. I hope all of you can see the screen. I have already shared the screen. Okay, you just there symbol. Okay, pin. You just pin it. If you pin, then I think you can see the screen. Okay,
Yes, sir.
can you see now? I hope all of you can see my screen.
Sir, I can see your screen.
Okay. So now I am asking you for FE415, what will be the value of sigma st? For FE415,
230.
yes. How much it will be, Marilyn?
230.
Yes, 230. It will be 230. Yeah, it will be 230. How you will get 230? From this table number 22, FE415 value will be 230. Okay, so sigma st value will be 230. So everything, the remaining part is same. You have to use the same formulas. Everything is same. See here, sigma st equal to 230. You have to find out m. Then the same formula, n equal to kd. Put the value of k. Put the value of sigma st. Everything is same. Okay, so I will not discuss this part because I have already discussed in the first problem. Everything is same, only this sigma st value is different. So I will not discuss again this part. Okay. Okay, so let us see the second problem. Let us see the second problem. Read the question. Find the moment of resistance of a RCC beam 300 millimeter wide and 500 millimeter effective depth is reinforced with 3 bars of 16 mm diameter. M20 concrete and FE415 steel is used. Okay, so we have to find out moment of resistance now. Okay, so now in the previous question, if you can remember the previous question, in the previous question it is directly mentioned. See here it is, balance section is mentioned in the previous section. In the previous question, it is written that your section is a balanced one. Okay, so but in this question, in the previous question it is mentioned balance section. Okay, but now in this question it is not mentioned whether the section is balanced or it is under reinforced or it is over reinforced. Nothing is mentioned. Okay, so we can't use the equation for balance section directly. This is the equation for balance section, moment of resistance for balance section. This is the equation of moment of resistance. Okay, so in the first question it is mentioned directly balance section, so we have directly used this equation. But in the second question, in this question it is not mentioned whether your beam is balance section or under reinforced or over reinforced. So first what our aim will be to find out what is the type of section, whether it is under reinforced or over reinforced or balanced. Okay, so our first aim will be that one. Okay, so now let us see the solution. So sigma for M20 grade of concrete, what will be the value of sigma CBC? It will be 7 from table number 21 of IS 456. Then for FE 415 from table number 22, sigma ST value will be 230. Okay, so next M equal to 280 divided by 3 sigma CBC. You will get this value. Now in this question, width of the beam is given. Width of the beam is 300 millimeter, this one, and 500 millimeter effective depth. So effective depth means small d is given. Okay, so next also it is mentioned that you are using 3 bars of 16 millimeter diameter. So total area of steel will be 3 into area of 1 bar, pi by 4 d square formula. Area of a bar is pi by 4 d square. We are using 3 bars, so sigma st will be 3 into pi by 4 d, diameter is 16. So we are getting the value of sigma st. Okay, we have got the value of sigma st. See, not sigma st, ast. Ast means area of steel. Okay, so next we have to find out critical neutral axis. Critical neutral axis means, in the last class I told you, for a balance section, whatever neutral axis we will get, that is known as critical neutral axis. Okay, so this formula, from where you have got this formula from? In the last class I have showed you this formula. This formula, this is the formula to find out NC. Okay, M into sigma CBC divided by sigma ST equal to NC divided by D minus NC. Okay, so see this formula, M into sigma CBC divided by sigma ST equal to NC, NC for critical neutral axis, D minus NC. This is the formula. So put all the values in this whole equation. Only unknown is our NC. Okay, so you will get the value of NC. NC will be 144.13. That will be our depth of neutral axis, critical neutral axis. Okay, it is the depth of critical neutral axis. Okay, NC you will get 144.13. Okay, this one. Okay, so now next our aim will be to find out the actual neutral axis. Okay, so for finding out the actual neutral axis, we have this formula, b into n square by 2 equal to m sigma ast d minus n. This formula also I have shared in the last class. In this PDF, if you can see, if you have gone through the PDF, this is the formula to find out the actual neutral axis. This is the formula to find out the actual neutral axis. Okay, in the last class PDF, I have given you the PDF. If you have gone through the PDF, you can see the formula. B n square divided by 2 equal to m ast d minus m. This n is your actual neutral axis. Okay, depth of actual neutral axis. Okay, so we have to use this formula to find out the actual neutral axis. So let us see the formula. This one. B value is given, n value we have to find out, m is known, ast is known, d is known. So only unknown will be n. So you will get two values of n. One will be negative, one will be positive. So you have to take the positive value. So now you have got n equal to 139.13. Okay, so now you have to compare the two values, critical neutral axis and actual neutral axis. So which value is more? From this two value, you can see that our critical neutral axis depth is more than actual neutral axis depth. So can you tell me what is the type of section? In the last class, I have shared the PDF. I have explained what is under reinforced section, what is over reinforced section. So if NC is greater than N, what will be the type of section? Whether it will be under reinforced, over reinforced, or balanced? Can you tell me from the last class PDF? If NC is more than actual neutral axis, what will be the type of section? Whether it will be under reinforced section or over reinforced section. Shiroda, can you tell me what is the type of section? Boruapang, can you tell me? Boruapang, can you tell me what is the type of section now? If depth of critical neutral axis is more than the depth of actual neutral axis, what will be the type of section?
Under reinforced section, sir.
Under reinforced section, yes, under reinforced section. Okay, good. So, comparing the critical and actual neutral axis, N is less than NC, therefore, critical neutral axis is below actual neutral axis, and hence the beam is under reinforced, and the moment of resistance of the beam will be calculated as follows. This formula also I have given in the last class PDF. For under reinforced section, this is the formula to find out moment of resistance. Yes? Okay, so now use this formula to find out moment of resistance. M equal to sigma st ast d minus n by 3. Sigma st is 230, ast is this one, d means it is given, n is our actual neutral axis, not the critical neutral axis. This n is actual neutral axis depth. Okay, 139.13, this value. Okay, so if you put all the values, your unit will be in terms of Newton and millimeter, because sigma st values, sigma st is in Newton per millimeter square, ast Newton per millimeter square, d is in millimeter, n is in millimeter. So moment of resistance, it is the force into distance. So unit of force is Newton in this formula, and the values you have put is in millimeter. So the value will be coming in Newton millimeter. So if you have to convert this Newton millimeter into kilonewton meter, what we have to do? We have to divide this value by 10 to the power 6. Because from Newton to kilonewton divided by 1000, from millimeter to meter divided by again 1000. So you have to divide this value by 10 to the power 6. So you just shift the decimal by 6 points. Okay. So 1, 2, 3, 4, 5, 6. So it will be 62.95. You can see the value 62.95. Unit will become kilonewton meter. Okay. Okay. So now, if I ask you one question, in any case, say you have got the value. So for this problem only, if this value is, if critical neutral axis depth is say less than actual neutral axis depth, then what we will do? What you will do? Say in a particular problem, you have got depth of actual neutral axis is more than critical neutral axis. This n value is more than nc. So in that case, what you will do? How to find out moment of resistance?
So the formula is different.
So your section will be under reinforced or over reinforced?
Over reinforced section.
Okay, so over reinforced section. So over reinforced section, your formula will be different. Okay.
Yes, sir.
Okay, so now did you understand this problem? Everything is given, only you have to remember the formula. How to use the formulas, you have to remember that. Okay, based on the values given in the question, which formulas we have to use, you need to remember those. Okay, and from which table you will get the value of sigma CBC and sigma S2, you have to remember. From table number 21 of IS 456, you will get the value of sigma CBC. Sigma CBC, this value you will get based on the value of this one, based on the value of concrete. Okay, based on the value of grade of concrete, you will get the value of sigma CBC, and based on the grade of steel, you will get the value of sigma ST. Okay, and this value you will get from table number 22 of IS 456. From table number 22, you will get the value of sigma ST, and from table number 21 you will get the value of sigma CBC. Okay, so let us see the next problem. I hope all of you have understood this problem. If you have any doubt in,
Sir,
yes,
can you explain this part? At third line, M is equal to 280 by 3 into 7.
this is the formula of modular ratio. This formula in the last class I have showed you.
Modular.
M equal
Okay.
to 280 divided by 3 sigma CBC.
Oh, yeah.
Yeah, that formula. M equal to 280 divided by 3 sigma CBC. This formula I have shown you, I think not in the last class. Before that, when I have showed you the different assumptions in working stress theory, I have shown you the value of M. M is 280 divided by 3 sigma CBC. Okay?
Yes, sir.
Okay, so I hope you have understood this problem. If you have any doubt, you can ask me now. Okay, if you have any doubt, anyone have any doubt, you can ask me. Otherwise, we will go for the next problem. These formulas you have to remember. Okay, this formula, then this formula, these formulas you have to remember. M is 280 divided by 3 sigma CBC, this formula. These formulas you have to remember.
Sir, please share this PDF, okay?
Huh?
Please share this PDF for the class.
Yeah, I will. No. After the class, I will share the PDF. After the class, I will share the PDF in the group, in your group. Okay, wait. I will share it now. I think it will be better, no? If I share the PDF now, it will be better, or after the class, if I share, then it will be better. You tell me. Okay, so let us see the next problem. Okay, so next problem you see, determine the moment of resistance of a RCC beam. Dimension is given, is reinforced with, this value is given. Permissible stresses in concrete and steel are given. Everything is given directly in this question, so no need to find out sigma, this one M. No need to find out sigma ST separately because it is directly given. No need to find out sigma CBC from IS code because these values are directly given. Okay, this is this one of the simple, very simple problem. You try to solve this one. Try to solve this one because all values are given. You see the formula. I hope all of you understand this one. B is given 350, 550 millimeter. It is given effective. Effective means effective depth. Small d is given. M is given 13.33. AST you have to find out 3 into pi by 4 d square. This one because we are using 3 bars of 20 mm diameter. So area of steel will be 3 into pi by 4 d square. So this is the value of AST. Then sigma CBC is given. Permissible stresses in concrete. That means it is the value of sigma CBC. This is 7. And steel. When it is written as steel, then you have to understand sigma ST value is given. This is our sigma ST 230. Okay. So first we have to find out, similar to the last problem, our aim will be to find out whether the section is balanced or under reinforced or over reinforced. then only we can use the formula of moment of resistance. Directly we can't use the formula of moment of resistance. Okay, if nothing is mentioned, we can't use directly the formula of moment of resistance. Okay, so similar to the last problem, we are finding out this NC, critical neutral axis depth. So you have got NC equal to 158. Then for actual neutral axis, same formula with the last problem. Okay, so now in this case, see the values. Critical neutral axis, depth of critical neutral axis is less than actual neutral axis. So in that case, what will happen? Our section will be over reinforced. So if over reinforced sections are there, how to find out moment of resistance? This is the formula. Okay, this is the formula to find out moment of resistance for an over reinforced section. I told you to see the last class PDF. I have shared the PDF with you. To see the PDF, this formula is given for over reinforced section. This is the formula to find out moment of resistance. And how to find out whether your section is over reinforced or under reinforced? Just compare the value of N and NC. N means your actual neutral axis and NC means your critical neutral axis. Okay, this is the condition for over reinforced section. So sigma moment of resistance formula will be this one. I hope all of you have understood this one. It is the same problem with the last one.
Yes, sir.
Okay, exactly same, but it is simple because in this question M value is directly given, sigma ST is directly given, sigma CBC is directly given. No need to see IS code for this problem. Okay, so this is more simple than the previous one. Procedure is exactly same, everything is same with the last problem. Only in the last problem these values are not given, sigma ST, sigma CBC and M. These values we have find out from IS code in the last problem, but here in this question everything is given directly. Okay, so other things are everything is same. In the previous problem we have got our section is under reinforced. Now we have got our section is over reinforced, so the formulas will be different. This is the formula for over reinforced section. So just put all the values, you will get the value in terms of Newton and millimeter. If you want to convert the value in kilonewton meter, just divide the value by 10 to the power 6. Your decimal will be shifted 6 digits. Just shift this decimal by 6 place, then you will get 100.59. Okay, and unit will become kilonewton meter. Okay, so I hope all of you have understood this problem also.
Yes, sir.
Okay. Okay, so let us see the third one. All of you try to solve the next problem. I won't show you the solution. You read the question and try to solve it. Read the question and try to solve it. Determine the moment of resistance of a singly reinforced. So dimension is given. Material is M15, Fe250, M is given. So find out the moment of resistance first. First find out the moment of resistance. Then we will see the next part. First you find out the moment of resistance. Exactly same with the previous problem. First part you find out the moment of resistance and you solve it and you tell me the answer. I won't show you the answer. All of you, this is the, okay, you see the formulas. If you don't remember the formulas, you can see the formula from the last class PDF. From the last class PDF, you see the formula and find out the moment of resistance. You solve the numerical now and you tell me the answer. Then only I will discuss this solution. Okay, Tochumi, are you solving the problem?
Yes, sir.
Okay. So did you get the answer?
I'm still in process.
Okay. Shiroda,
Sir,
yes.
first we have to find the
NC,
value.
top critical neutral axis. By this
We
formula,
have to find AST, right?
AST,
AST also.
AST is, it is written here, na, 4 bars of 16 mm diameter. So it will be 4 into pi by 4 d square. D value is 16. Area of steel.
D square.
Area of one bar is pi by 4 d square formula, na? Because our bar is circular bar, na? So area of a circle is pi by 4 d square.
Oh,
Our steel bars are circular or not? Okay, तो अच्छा.
yes, sir.
Our steel bars are circular or
Yes, yes.
rectangular?
Okay, keep on.
Our steel bars, whatever we are using in building or road or anywhere, those are circular in shape or rectangular in shape.
Circular.
So
Circular.
area of a circle is pi by 4 d square. So in this case, we are using 4 bars. So
So I got AST.
yeah. Okay, so then you find out NC, depth of critical neutral axis, by this formula. Bemishal Debbarma, Bemishal Debbarma.
Sir, sir, is NC 117.2.
NC is how much?
117.2.
Okay, then you find out the value of NA, actual neutral axis. You complete the problem and tell me the answer of moment of resistance. Have you got the answer? Actual neutral axis how much? Okay, what is the value of Na? You are taking so much time. You don't have calculator with you. With calculator, you just put the value, you'll get the answer within 2 minutes. Shiroda, 31 students are present. Not a single student can solve this problem. Why? Why you are taking so much time? I have shown you the formula. All values are given. Then also why you are taking so much time? Okay, I will show you the answer. You just see the answer. Otherwise, okay. This Na value will be 159.5. NC is 117.4. Okay, so if you compare both the values, you will get our section is over reinforced. Okay, so for over reinforced, this is the formula to find out moment of resistance.